Hello students, welcome. Today, we will be going to discuss the topic 4, which entitled Underwater Sensors and Acoustic Instruments. So here are for the authors and contributors of this material, and here is for the copyright notice. For the intended learning outcomes of this lecture, after this lecture and exercises, the students or you the students must have first identified and described the use of acoustic instruments such as echo sounders and SWAT sounders or multi-beam sounders. And second is to learn how to operate an echo sounder. But since we are on this situation or in this setup, mga online tanan, so I'm going to give you the concept on how the echo sounder is being operated and how echo sounder works. For the outline of this presentation, we have 5 parts. The part 1 will be talking about echo sounder operations. The part 2, the single beam echo sounders. The part 3 is the multi-beam echo sounders. Part 4 is the side scan and oblique sonars. And last, for the part 5, is the airborne laser method. So let's start with the part 1, which is talks about echo sounder operations. In bathymetry, the object to be positioned is frequently the seabed. So the target here, kung mugamit tag echo sounders, of course, our target feature is the seabed. And usually, the horizontal position of the surface vessel is obtained first. So, mo nang, as you can see, kung kinsa naman kayo nakakita sa inyo na nag-bathymetric survey using echo sounder, so there is a GNSS receiver attached to a vessel or a boat, so that the horizontal position of your vessel is being known. And then the distance between the vessel and the seabed, like for example, we're going to measure the depth, is being determined. So the setup here is the GNSS receiver is attached to a boat and also the echo sounder. So the GNSS is for horizontal positioning, and the echo sounder is used for determination of the depth of the water bodies, sa kung asa nakalocate ang inyong vessel. And in modern hydrographic surveying, depth is observed or determined from observation of a travel time of acoustic waves. So we are using sound waves here. So the time that elapsed, if the echo sounder is being emitted, a sound waves going to the target, which is the seabed, and bounce back sa sensor, which is the echo sounder. So ang time na niya is determine na siya using the acoustic waves. Kung kamusta siya mubalik, bounce back to the sensor. So the acoustic pulse transmitted by a transducer vessels through the column of water and then reflected by a target. So this is what I am discussing kanina. So mo-emit siya or transmit siya og acoustic pulse or sound waves going to the target, which is the seabed, then bounce back. Pag ma-reach na niya ang seafloor, then bounce back going to the sensor. So here is the illustration on how the depth is being calculated using or from the measured travel time, which is denoted as the change in T. So we have here the formula that to get the depth is just C times the change of time over 2. So where C daw is the speed of sound in the water, where T change in T over 2 times the speed of sound in the water. So anong times 2 man siya? It's because the time that travels from the where the sound waves is being transmitted from the echo sounder, then pag reach niya sa seafloor, then bounce back. So duha siya ka travelan niya sa water. So mo na siya i-divide siya 2. And times dayon sa speed of sound in water. The basic echo sounder used to measure the pulse in two-way travel time through the water column consists of the following components. So mo na niya mga components sa echo sounder. First is we have transmitter. si transmitter ang mag-generate sa pulses, no? So mo-transmit siya og pulse or sound waves padulong sa target. Next is we have the TR or the transmitter receiver switch. So si transmitter receiver switch is which siya ang magpasa, no, og power to the transducer. Then next is we have transducer, no? Transducer is being mounted on a ship's hull, so mao ni siya ang gi-connect, no, sa boat, no, which converts the electrical power into acoustic power. Then sends the acoustic signal into the water, then siya pud ang mag-receive sa echo, iring i-convert into electrical signal, then ibalik na pud niya sa transmitter. So now sa receiver, siya ang mag-amplify the echo signal and sends into the recording system. So after kang transducer, balik ang receiver. Padulong kang receiver rather. The next is sa recorder, no? Recorder which controls the signal emission, measures the travel time and acoustic signal. Siya ang mag-store sa data and converts time intervals into ranges. Again, transmitter mag-generate sa pulse. After sa transmitter going to the TR switch, siya ang magpasa power into transducer. Karon si transducer is kanang makita nato sa boat nga gi-attach sa boat rather, no. Then siya ang mag-convert, no, gikan sa electrical signal or the power into acoustic power. Then iya nang i-send padulong sa target which is ang seabed. Afterwards, siya pud ang mag-receive, no, sa echo nga ni bounce back gikan sa seabed. After that, si receiver na dayon ang mo amplify sa katong echo signal nga iyahang na-receive from transducer, then iya dang i-send sa recording system which is ang recorder na nga part. Controls the emission, siya nag-measure sa travel time, iyang i-calculate, i-store ang data, and i-converts niya ang time into ranges. So basically here is the flow, no, on how the echo sounder is being worked, or how echo sounder works, no, rather. So transmitter, then going to TR switch, no. Si TR switch padulong dayon kang transducer, mo ni siya ang nalubog sa tubig, no, which is si transducer, siya ang mag-emit og signals padulong sa target which is ang seabed, then bounce back ang echo or ang sound waves, siya pud ang mo-receive sa transducer. After that, balik ang TR switch, iyang pasa kang receiver, no? Then si receiver, then si recorder dayon, which is ang mag-analyze na dayon. So let us discuss more about transmitter. So the transmitter is being equipped with a quartz clock that oscillates in the range of 1 to 10 MHz, whose frequency is divided down to obtain the operating frequency of the transducer. So the quartz clock is also used to measure the time interval between the transmission and the reception of the acoustic signals, and modern echo sounders usually offer a choice of 2 to 3 transmitting frequency, namely the low frequency, which is very effective in deep water because the attenuation is being lowered, but it requires a large transducer, and a high frequency transmitter. This is the transducer can be compact, but high range is more limited due to higher attenuation. So again class, si transmitter is na siya quartz clock, no. Kani si quartz clock karon ang mag-measure sa time, no, by its term clock, no. So siya ang mag-measure sa time, no. It's because it has a range, no, na oscillate siya into 1 to 10 MHz. And there are two choices, no, in 2 or 3 rather, na transmitting frequencies. We have low frequencies, which is used in deep water, no? Tungod kay ang attenuation is lower. And pero if low frequency imong gamiton ng transmitter, you are going to use a large transducer. And if high frequency, so the transducer can be compact but the range is more limited, no, due to high attenuation. Pag low frequency, low ang attenuation, and high frequency, higher ang attenuation. So again, no, here nga part is si transmitter. Naa siya quartz clock. Example sa quartz clock is kani siya. Gamay lang siya nga clock, then naka-equip na siya into the transmitter. So next is the TR switch, no, or the transmitter receiver switch. This is used to trigger the pulse, no, with a specific length. No, normally ang pulse length niya is usually varies from 0.1 to 50 milliseconds. So in shallow water daw, a single short pulse of a length of 0.2 milliseconds is transmitted and received before the next pulse is being transmitted. Okay, of course, shallow man ang water, so gamay lang ang iyang length of pulse. No? And in deep water, many pulses of lengths varying from 1 milliseconds to 40 milliseconds are generated and are in the water at any time. So paspas, no? Paspas paglawom. And the variety of pulse length helps to overcome losses due to attenuation. So when we say attenuation class, it is a general term that refers to any reduction in the signal, strength of signal. So murag pahinay kumbaga, no? So kung if the pulse is being transmitted from the transducer as it goes into the water, no, labi nagpalawom na siya nga palawom, there is a reduction of strength of signal, no? So attenuation is occur, no, with any type of signal, whether digital or analog, and sometimes attenuation is being called loss, no? And attenuation is a natural consequence of signal transmission over long distances. So kung mo travel siya into taas na distances, there is a possibility of attenuation, no? And in remote sensing class, attenuation is the dimming and blurring effects of remotely sensed images caused by absorption and scattering of light or other radiation that passes through the Earth's atmosphere. So ang term na attenuation sa remote sensing is kanang blurring effect sa imuhang images nga makapture, no? It's because as the signals, no, electromagnetic signals is being emitted from the sensor, no, above, so moagi man na siya og atmospheric may atmospheric errors, no? So therefore naay there is a reduction of the strength of signals that is being transmitted from the sensor. So mo na ang iyang output is there is a blur effect or dimming effect to the images. So here is the example of high frequency and low frequency nga signals, no? So there is a pulse envelope shape, no? Ingani ang forma na sound waves, no, padulong sa target. So kung ato ni siyang this one, ato ni siyang i-zoom, no, kumbaga dili nga part. So ingani ang forma niya. So this is a portion of sonar pulse, no, to show individual cycles. Marja po siya og normal wave. Next is the receiver. So the receiver is the one who amplifies the returning echo, no, or signal and sends it to the recording system. So once again, sa atong i-discuss sa ganina, once the signal is transmitted by the transducer, no, and ma-receive niya balik ang echo, siya na din ang i-transfer din ni or i-pass din ni transducer into the receiver to amplify those returning echo. No. And the receiver is being equipped with a time-varying gain or TVG, which is used to reduce the gain to the receiver immediately after transmission in order to filter out the reverberation. So si a receiver na karon ang mag-analyze, no, sa kay iyamang i-amplify ang echo nga na return, no, which is gathered, no, by the transducer. So ira nang i-filter out, no, ang mga reverberation. So the receiver gain returns as the exponential function of time, and the receiver bandwidth must be wide to accommodate the Doppler shift of the transducer if the transducer is not vertical. No, in case daw ko, no, if there is a speed lag. It's because the transducer man, no, naaman siya na nalubog man siya sa water, no? And as the speed of the boat, no, nga mo travel, so there is a Doppler shift, no, nga mahitabo. Okay? Like for example, there is any disturbances like ang current na forces, no? Current forces from the water, no? As the boat is traveling, no, towards any direction. So again, no, so transmit the pulse from transducer, then i-sense balik ni transducer, then balik din muagi pa siya kang TR switch, then padulong na din kang receiver. Siya na din rin ang mag-calculate, i-transmit, i-filter, so alright, so let's talk about Doppler shift. So the Doppler effect or the Doppler shift is the change in frequency of wavelength or a wave in relation to the observer who is moving relative to the wave source. So example ano niya class is imagine yourself that you are standing here, no, in this portion, and another person is standing here, no. So as ang kaning truck or ang kaning car, let's say this is a fire truck, no, no. As the fire truck goes towards padulong sa imuha, no? So kung sa layo pa si fire truck, no, dili mo siya dili kay nimo madungog ang tingog or hinay lang kaayo ang tingog. Compare nimo kung mas duol na si fire truck sa imuha, kung naa na siya diri nga part, so mas kusog na ang imuhang tingog nga madungog, no? So let's compare nga mas duol na sa imuhang observer, mas duol na sa imuha ang fire truck, i-compare na to sa person na nagstand opposite side sa imuha. So mas duol na sa imuha ang fire truck, mas high ang frequency sa sound, which is mas kusog, no? I-compare nimo sa another person na nagstand opposite side sa imuha. Kung magkaduol na siya sa imuha ang fire truck, ang another person na nag-observe sa opposite side is mas hinay na tigdang iyahang madungog na tingog kay it's because of the low frequency, no? So yan ang Doppler effect or Doppler shift or Doppler effect. So same lagi hapon na siya sa bathymetry, no? So dapat ang ato adong transducer is wide enough, no, to accommodate those Doppler shift. Okay, for example, there is a forces, no, external forces like current or current sa tubig, no? So dili kay siya vertical ang imuhang transducer katungod kay naa may force sa ilalom nga sa tubig, no, kusog. So there must be a change of waves, no, as it goes to the target, which is the seabed, no? Okay, it's in relates man gihapon sa speed of the boat, no? So mao nang dapat kung mag-bathymetric survey dapat ang speed sa boat, no, must be constant. Dapat kung 5 meter per second, dapat 5 meter per second na gyapon along mahuman nimo ang imuhang area, no? So para ma-avoid na to ning Doppler shift. Alright, so next is the transducer. So transducer is being mounted into the ship's hull or gi-attach mo ang pasabotan niya is gi-attach lang siya sa ship, no, and is in contact with water, no? The function of the transducer is to convert electrical power into acoustic power, no? Then it send acoustic signals into the water, then siya pud ang mag-receive sa echo of the acoustic signal, then siya ang mo convert to the acoustic signal to balik na pud niya into electrical signal para na pud ma-transfer na pud niya itong electrical signal into the receiver. So yung example niya sa transducer, mo ni nakalubog sa what do you call this one, mo ni nakalubog sa tubig, no? And kani is it's kinda tube siya, no, tube, tapos naka-attach ni siya sa boat, no, which is mabutang pud ang iyang cable sa sulod para maprotektahan ang wires. So this kind of transducer is a piezoelectric transducer. So ingani siya class, no, ang transducer. So there is for example, this is a boat, no, then transducer mo ay nakalubog sa tubig. So there's a sensor, like for example this one, no? ingani siya kasagaran atong makita nga transducer. So ingani pod ang naasa sa Geo no nga transducer. So nakalubog na siya sa water, siya ang mag-emit og signals padulong sa target, which is ang seabed. So this kind of a ecosonder operation is multi-beam, no, multi-beam. So na siya series of single beams na mo collect og data. And also it is equipped with a GPS or GNSS. So the electrical pulse, no, from transmitter causes the diaphragm of the transducer to vibrate. No? After the vibrate, nga mo vibrate siya, the vibrating diaphragm, which is in contact with water, siya na dayon to mag-generate sa acoustic wave. No? So from electrical pulse, there is a diaphragm in the transducer that causes, no, how to vibrate. Then those vibrating diagram, siya na din ang mo generate of acoustic wave from transducer. The opposite process occurs when receiving signal. The vibrating diaphragm generates an electric current which is sent to the receiver. So mo na kung gibalik-balik na nga discuss kanina, after nga madawat ni transducer ang echo from the seabed, no, then it will be going to goes to the receiver. Then the transducer can be based on different principles. There are three types of transducer that are briefly presented. First is a transducer of magnetostrictive material. Second is piezoelectric transducer, and third is an electrostrictive transducer. Kung isa-isahod. So first is the transducer of magnetostrictive material. So this transducer uses the property of magnetostrictive material. Example is a nickel. And changes its length into the presence of magnetic field. So it uses magnetic field, no, na example niya nga material is ang nickel. A particular beam shape of the acoustic signal is obtained by configuring the array of elements according to the specific patterns. So next is the piezoelectric transducer. So it uses the property of a certain crystals called the ammonium dihydrogen phosphate that change length when a potential difference is applied into electrodes on the opposite faces of the crystals. So ingani yung example class na. It's a piezoelectric transducers. So na ay quartz crystal na made up of ammonium dihydrogen phosphate. So mo ni siya malublob sa tubig. So next is the electrostrictive transducer, which uses the property that ceramics change length when placed in an electric field. Ceramics can be molded in a desired shape, and elements are mounted between the face and the tail of the piston to obtain desired beam width. So ngani pa ang iyang forma na. So na ay piston, then we have ceramics molded na desired sa iyang shape, and here is the properties, no, or the composition of the electrostrictive transducer. Alright, so much for the part 1. Let's go to the part 2, which talk about the single beam echo sounders. So the beam width of a conventional single beam echo sounders or SBES is usually in the order of 30 degrees. So kung maingon tag iyahang order class, it's the ang buka kumbaga sa iyahang coverage, no. And however, narrow beam echo sounders with beam width, so that's beta, no. Kung ang kanang kabukahon niya, that's 2 theta, no. So ang 2 theta is 5% lang, no, ang iyahang 5% rather, 5 degrees, no, 5 degrees rather, have also been available since in the mid of 1980s. And operation of the narrow beam echo sounders requires a transducer to be mechanically or electronically stabilized, no, for roll and pitch motion. So ang roll is for horizontal motion, and ang pitch is for vertical motions. Since kay na may mga external forces, no, like currents, waves, no. So dapat stable si imong transducer for whatever roll and pitch nga motion. So what I am trying to say in the katong 30 degrees class is kani siya, no. So kung ato na siyang kuhaon dira ang angle, it's 30 degrees, no. But nana pa available na narrow single beam, no, which is equal to 5 degrees as stated in the previous slides. Ingani ang example sa single beam. Isa lang kabuk ya ang emit og acoustic sound or acoustic waves. Then kung unsa tong directly below sa kani imong ship is mora pud ang iyang ma-cover. That's single beam. And narrow beam echo sounders are used to first obtain depths directly under the vessel. So mo na kung giingon kung na class, no. Ang kung unsa lang ang tong directly below sa ship, mo to ang iyang makuhaan rather of information. Thus avoiding the wide beam biases caused by underwater slopes, no. This depth is used, no. It's either for safety navigation or seafloor mapping. So ang output ni narrow is for pwede siya for safety navigation purposes and for seafloor mapping. And narrow beam echo sounders also are used to improve the quality of data in terms of both resolution and accuracy. If you are going to check the accuracy of a specific data, so pwede siya, no, si single beam echo sounders ang ganito. So that's the operation for single beam echo sounders, no. So na siya beam width kani class, that's the beam width. Pero ang iharang data nga makuha is directly below the vessel, no, kani siya. So emit siya og sound waves, then pag-abot sa seafloor, bounce back, then i-record na dayon siya. That's the single beam echo sounder. Next, for the part 3 is the multi-beam echo sounders. For multi-beam echo sounders or MBES, no, it's a system that are used to increase the bottom coverage, no. Kay since si single beam is directly below lang sa vessel or sa boat, no. Kani si multi-beam is from the word multi, no, daghan siya makover. So ma-increase ang imong bottom coverage, so dako na ang mas wide na ang makover niya sa ubos, and consequently ang iya pong productivity, no. Each of the narrow beams produce yields a resolution of a bottom equivalent to that of a narrow single beam echo sounder. Mas dako siya og makover and also the resolution. The measurement accuracy is not better than, no, the single beam echo sounders, of course, no. Murag kung atong i-compare si multi-beam o si single beam, mas okay ang gyud ang accuracy ni single beam kay isa ra man jud ang iya makuha nga data or information. Pero when it comes to coverage, mas kuan jud si multi-beam, mas dako siya coverage. However, in fact, accuracy decreases as the SWOT angle increases, no? So kung ang iyahang kung dako ang iyahang makover, no, at that instant, mas mo-decrease pud ang iyang accuracy. So kung magka-wide ang iyahang beam width, magka-decrease pud ang iyahang accuracy, no? So this is the multi-beam echo sounder. So from the sensor, there are series of single beams, no. Murag gipadaghan lang kumbaga siya ang single beam sa isa ka instant nga pagkuha sa information or sa data. So the multi-beam echo sounders are divided into two groups, namely the SWOT system and the sweep system. A SWOT system produces multiple acoustic beams in a single transducer system. So from the word itself, or masabtan naman, no, si SWOT isa ka transducer, daghan siya ma-emit nga acoustic beams, no. Murag parehas itong kaganina kani, no. SWOT isa ka transducer, daghan siya ma-emit nga what they call this one, single beams. And although dual transducer system are used, and sometimes the transmitter and receiver are separate. A sweep system, no, on the other hand, a sweep systems are simply consist of array of single beam echosonders mounted on booms deployed in a side and perpendicular to the surface vessel. Most of this section will deal the SWAT systems with an introduction to sweep system at the end. So basically, di ba ang SWAT is from the single transducer mo image siya daghan og single beams. Well, sa sweep is array lang siya murag like for example na kay mo na imong boat, no, diri imong boat, din na kay murag ibutang diha ang perpendicular sa imong vessel, tapos na diri single beam single beam diri single beam na pod, murag imuha lang gipang butangan og single beams, no? Ako na ipakita later on sa pasabot sa SWAT system. So sa SWAT system ingani to class, no, there is a isa ka transducer, then multiple dayon nga single beams. That's for SWAT systems. And here is for the sweep system. So from the boat perpendicular, then naa din siya kani single beam ni siya, single beam. That's for the sweep system. So multiple siya kay at the same time you gather all the depth of the specific single beams na mga single beams echosounders, no, at the same time. So dako gyapon ang coverage nga ma. So that's for the sweep system. As SWAT and multi-beam echosounders transmit an acoustic pulse in a wide fan in one direction, no? So pwede siya in a fore and aft, no, or at warp ships, no, then this results in a wide footprint, no? So single man nga transducer, then multiple dayon nga mga single beams, it results into a wide footprint, no, in a specific direction. The backscattered signal is received by a transducer, no, with which segments the above wide footprint to multiple smaller beams. Mani akong discuss sa ganina. The wide of these beams is of the order of 1 to a few degrees, depending on the system. In this manner, a high number of depth soundings are generated in each pulse transmission. Tungod sa iyang kadako or kayahang wide yung coverage, mas dako po ang iyahang ma-gather na information. A line of soundings is obtained from a single vessel's track rather than single line of a soundings. Mura siya og strips nga agi, tapos dako siya. Mura siya gaagihanan kumbaga ba nga dakan kay single beams na mo gather information, tapos ang boat is nagdagan. So basically dako gid siya nga coverage na, and napoy tendency nga magka-overlap, and overlap is okay, no, para ma-assure na to ang 100% nga coverage. And so again, no, this is the footprint mo ni imong ship or in boat, then padulong dito imong direction. So this is the footprints, no, as the boat travel along track, no, mo po di ang coverage nga makuha. So the advantage of the multi-beam echosounders as compared to a sweep, no, system or a multi-single beam approach is that similar to a wider coverage is achieved when a shallow waters using a much more compact system. In the deeper waters, the coverage is much wider and can be several times the water depth depending on the NDES specification. So advantages should si multi-beam when it comes to kung dako ang imuhang area na i-cover or ang imuhang i-survey. Of course, mas dali ang time, no? At the same time, makita gid nimo ang whole coverage sa isa ka area. No? So this is an example, no, on how the kung unsay relationship between the SWOT angle to the footprint, no? So from this vertical, no, or sa directly below sa imong transducer padulong sa katong unsay ang maximum nga angle, that's the SWOT angle, no? Ang beam is kanino, like for example kani nga multi-beam is na tulo ka single beams, no? Tulo ka single beams. This one is first single beam, second single beam, and third single beam. So from the there, no, directly below padulong sa katong last nga single beam, middle pod niya, that's the maximum SWOT angle, no? And ang kani is for the what they call this one, this is for the beam width, rather narade ang term beam width, beam width siya. So kung magkadako ang imong SWOT angle, magkadako imong footprint, na ingana ang iharang relationship. So here are some important facts about multi-beam echo sounders. First is the survey line spacing is selected such that the neighboring SWOTs are overlapping in order to avoid gaps. So this is very important, no, or it's really important, no, based pa sa ako ang introduction last time, no, nga there must be a sufficient line spacing para makover tanan ang specific area na inyong gusto i-survey. So the ship's speed can also be selected such that there is 100% measurement overlap in order to enhance the reliability. So makaapekto gihapon ang pagkusgon sa dagan sa inyong boat ni gigamit, or the shall we say the boat that you are using, no, kung sa kusgon ang dagan, kung makaapekto na siya kay based pa sa itong i-discuss ganyan, naa siya attenuation na ma-encounter na error. And also kung constant ang ato ang ship speed, so there is a reliability, ma-enhance ang ato ang reliability sa data. A multi-beam echo sounder can be mounted in a vessel, no, which can be permanently or it can be temporary. So kung na-adjay vessel na siguro kung that ship is intended for hydrographic survey, so it can be permanently attached. Pero pag dili, labi na ka ng dili usual ninyo nga work is ang hydrographic survey, so it can be temporarily. Deep water transducers are large, which can up to 5 meters arrays, and it can be must be, no, permanent siya. The next is the ship's size has to be sufficient large to support the transducers. No, kung kintahay dako na kay ang transducer, so dili siya pwede sa kanang pangbangka lang, no. Ang ship na gid siya. Or kung kintahay shallow ra ang water, so dili man gid dako nga transducer atong gamiton, no. So suitability of the transducer as well as the vessel must be properly selected. And shallow waters are much smaller, no, in transducers. Okay, mabawra man sa man akong ganyo ganina. For portable use, a rig which can be attached to a bow or a launch can be used to mount the echo sounder and motion sensor. Once the rig is calibrated, it can be moved from one vessel to another without need of recalibration. So it's important that your instrument or equipment that you have used is calibrated, no, para ma-enhance ang atong accuracy sa ito ang data. So this is an example of a plan, no, plan kung asa niyo paagihon ang inyong or asa ninyo ipasubay ang inyong boat or inyong ship upon doing the hydrographic survey in this portion, no? So it must be properly planned. And these are the effects, no, of residual angular ship motions. So mga error na po ta, talking about errors. The total list of the multi-beam echo sounders error and error sources is much longer. So the most important are the system measurement errors due to system electronics, no. Kumbaga kabalo na mo sa system errors, no, kanang sa instrument mismo error. Then we have also depth measurement error due to beam width, no? Kung kintahay dili dili suitable ang beamwidth nga inyong gigamit, no? Or kung dili siya properly vertical ang inyong gigamit na properly vertical ang inyong echo sounder, so nahiwi siya, wa inyo na plaster og tarong, so that can cause an error. So effect of beam angle error, no, due to systems electronics, pwede po siya. Then the effect of this error increases the swath angles. This error is therefore more significant than the single beam systems, no? So beam angle error can be mas mahitabo siya usually sa single beam systems. Another one is the acoustic propagation errors. So these errors increase with the swath angle due to the ray bending effect, and are similar to the concept of RF propagation in the atmosphere, geometric propagation. Kung gintahay, as the acoustic waves travels in the water bodies, no, napod siya ma-encounter na error. So same gyapon sa remote sensing good. If there is a electromagnetic radiation from the above, so maagi man siya sa atmosphere, so there is an atmospheric error. So same with this in the multibeam echo sounders. Okay, since we are using acoustic waves, so there is a error, no, upon traveling in the water body. Effect of attitude errors such as roll, pitch, and yaw, no? This error increase in swath angle. So ang kaning roll, pitch, yaw, movement in the vertical, horizontal, or in z-axis, no? So napo ni sa inyong photogrammetry, no? Photogrammetry, the effect of the movements, no? Movements of the airplane. So kung diri gyapon sa hydrographic survey, naadya po na siya. And beam steering error due to surface sound speed error. Another one is the transducer misalignment error. Again, balik ta. Kung dili niya properly attach, kung dili siya kanang mas dali ra siya kung gamay lang current nga forces kay misalign na din ang imong transducer. So dapat tarungon siya og plaster, tarungon pud siya og kanang dapat firm gid ang pagkahikot sa iya, para to avoid errors. Heave, dynamic drought, and water level errors, no? Same as the single beam echo sounders. And we have also system calibration errors. If your equipment and your instruments are not properly calibrated, so there might be an error, no, na ma-occur. Of course, lastly, no, the tides and or other water level effects. Kanang balod sa dagat, no? Tapos din sa current sa tubig, so maka-affect na siya, cause of error. So we have also a vertical acoustic sweep system, no? This consists of a linear array of evenly spaced transducers mounted on booms, no, attached perpendicularly to the vessel, no? These systems are used in the critical shallow calm water areas, no, like harbors, channels, etc. for 100% coverage. The coverage of the bottom is 100% depending on the transducer spacing and water depth. So vertical acoustic sweep. So this is the sweep system. Na ikuan diri transducer. So the series of transducer to ensure the 100% bottom coverage. Again, ginagamit ni siya sa shallow, critical shallow, and calm ang water areas. So for the part 4 is the side scan and oblique sonars. So a side scan sonar is basically it's a transducer, no? Gi-mount lang obliquely with respect to the major axis of the ship. So from the word itself, side scan, no? So sa pangkilid lang siya, or ang imong transducer is being obliquely attached, no, with respect to the major axis of the ship. So the side scan sonar is primarily used for interpretation between sounding lines obtained with a single beam echo sounder. So pang what do you call this one? Pwede nimo siya i-attach kauban ang single beam, no, single beam plus side scan. Ganyan na siya. It can also be used to detect obstacles and hazardous to navigation even in the multi-beam echo sounder is being used. So kay pag dili naabot nung sa multi-beam, fully 100% bottom coverage lagi siya, pero ang kanang like for example river banks no kanang sa kilid na nga portion, so mogamit og side scan para makita nato kung unsay na-added to sa kilid. It is widely used for harbor and navigation of channels to ensure obstacle detection between sounding lines. No? Pwede po siya nga pang-reconnaissance, si side scan and oblique sonars. A single side scan is performed using a hull-mounted transducer to one side of the vessel's track, while a dual side scan is performed using two transducers mounted obliquely on each side of the ship or a towed fish. No? Towed fish na concept. So this is an illustration no, of a single side scan. Pamaagi na sonar. Sa botra, side scan from the word itself, no, sa kilid lang na portion. Like for example, for this one, so diri ara nga part ang iyang ginakuhaan. Kasi doon, for example, doon siya riverbed. No? And ang concept niya is there is a transducer sa isa ka ship, which is ang iyang coverage is the first part, diri nga part, no? Diri nga part. Pero pag nanapoy sa PCAS, that's what we call dual side scan. No, pag single side scan, kanilang diri nga part. Then there is also another ship, no? Nga naa siya cable nga nagbitbit pud siya og towfish or toadfish ang tawag nila anak nas. Moro ja pud siya og kanang nakasubmerge nung there's a somewhat like a thing or a material no nga gi-attachan pod og transducer. So kibali duha ka transducer siya. First is ang sa main nga ship and next is ang katong nga sa toadfish. Nga naa pod siya transducer. So ingani ang concept sa side scan. So a two fish mounted transducer, one on each side, no, are typically installed in 10 degrees below the horizon for the horizontal coverage and therefore for good obstruction detection. And the beam is a rectangular shape and the beam width is of the order of 30 degrees in a vertical plane perpendicular to the vessel's heading and 1 to 2 degrees in the horizontal planes. And side scan sonars can therefore cover wide areas and are useful to detect rough topographic irregularities. Okay, since iya mang i-scan duha na transducer ang available, so this is useful no in detecting the topographic labi nagnaay changes na labi na sa fossils and other formations no nga nasa ilang features. So here is a illustration on how the side scan sonar transducer and beam patterns. For horizontal, so naa siya 1 to 2 degrees no nga discrepancies, and also sa vertical is we have 30 degrees based atong na i-state yun na sa previous nga slide. Then the extent of the coverage of the seabed by side scan sonar depends on, first is a beam width on the vertical plane. So katong 30 degrees no. So kung mas mali imong pagka measure or mas dakuan nimo or mas gamayan nimo ang iyahang degrees, dili siya based sa standard, so maka apekto gid siya sa extent or ang coverage nga makuha nimo sa information. Next is the tilt of the beam axis with respect to the horizontal. The same kung natay vertical aspect, naapod tayo sa horizontal aspect. Again, pag dili na to siya masunod ang katong gihatag nga standard, so therefore na-adjust siya effect no sa coverage. Next is the height of the transducer above the seabed. For example, class, dapat mahibaw-an nato no, mahibaw-an nato kung sa bathymetric survey man good based ako na experience no. So before ang survey no, before pa mag-conduct ang bathymetric survey, ginakuha na namo ng measurement nga atong height kumbaga no, kung pila to ka meters ang nalublob sa tubig sa transducer. For example, this is the sea surface, no, or kung sa bangka, then nakalublob man to imong transducer, nakalublob siya. So kuhaon nimo tong distance or ang height mismo gikan sa transducer padulong sa water surface. Okay, i-minus man na nimo siya sa pag-calculate. So same ra gyapon ani, no, the height of the transducer above the seabed. So kung mas lawom or mas somewhat like murag nakalublob jud siya kaayo, no, then naay mga irregularities sa seabed or sa riverbed. So na siya discrepancy or na siya effect, no, sa extent sa coverage, no. Kay kung for example kung mabaw ra or shallow ra imuhang hydrographic survey or imong surveyhon, tapos gabi kalublob imuhang what they call this one, imuhang echo sounder, no. So gamay na lang ang yan nabilin nga height na which is at i-travel sa iyahang kumbaga sound waves, no. Same ra gyapon sa kanang concept sa camera good, no, nga kung mas iduolim siya sa surface, so mas mo zoom in siya, so mo gamay ang iyang coverage, no, while kung musaka, no, yung isaka ang imuhang camera, mas dako ang coverage ang iyang ma-cover. So same ra gyapon ingani sa concept na. Next is the power of acoustic transmission, frequency, and the echo. Mao to yung pinakalas na dependent, no, kung unsan dependent nga makaingon ta nga dependent kumbaga, no, ang extent or ang coverage nga makuha, no, sa side scan sonars. So another one is the oblique mounted sector scan sonars or the sounders are used to seabed searches in dangerous shallow water, no. From the word itself, oblique, no, sabot gitilt ang iyahang nakatilt ang iyang transducer. So the idea is the vessel remain at safe water while mapping the seabed alongside. Both in vertical and azimuth scanning modes are being used in the system. So for example class, gamit ni si oblique mounted or oblique sonars is kanang itahay na nag-survey ka river, no. Then di na mo ma-cover tong nasa mga river banks, no. Okay, say for example basin mabaw na ito nga part, no. So si oblique mounted is used, no, to have a coverage, no, na ang atong data makakuha gyapon tag data dito sa kanang kilid sa river banks, no, kilid. Okay, gusto man to 100% water seabed coverage or riverbed coverage. So katong mga part na dangerous na, like for example na mga debris or mas mabaw na siya compared dito sa tunga-tunga, so si oblique sonars ang gamiton. So here is an illustration on how the oblique sonars are being utilized, no. From the word itself, oblique, no. So kung padulong dito ang imuhang ang imuhang ship or imong vessel, so naadiri ang atong transducer, ang iyang coverage is just naka-oblique, no, naka-oblique siya gikan sa vertical. So ang iyang ma-cover is kaning diri ang part kaning. Unlike sa multi-beam o single beam nga ang directly below sa transducer is mo iyang ma-cover. So ang kani is naka-oblique man siya, so ang katong ang nakita ra pud niya obliquely mo ay makuha na information. Another illustration, no? So if this is the transducer, dito padulong ang water or ang depth sa water. So ang iyang scan is diri mo ni siya ng mga single beams iyang makuha. Then kani na elevation or depth rather, no, depth. So nga na ang concept sa oblique sonars. And the basic observable in the side scan sonar is the two-way travel time. Same ra gyapon sa pamaagi sa multi-beam and single beam. No information is available on the direction of the reflected signal, and as a result, a side scan sonar may not produce reliable images of areas that are not flat. Ano makaingon man ta nga dili siya reliable in not flat? For example, in this illustration, this is the terrain of the seabed. So this is the single beams, no? Dira mo travel ang sound waves, no? Bounce back, tapos makuha ang echo. And as you can see, class, no? From 1, 2, 3, 4, okay pa. No? Okay, makarakterize pa niya ang changes sa elevation. But as you observe in the 5 and 6, no? Dili, murag, kumbaga, kung ato ni siyang i-plot using the data nga nagather aning 1, 2, 3, 4, 5, 6, nilargo siya dito sa 5. Murag, kumbaga, from 4 nga pa-upward, down din siya largo sa 5. No? Kung ato siyang i-plot. Pero in the reality, no, or naa dito sa ilalom, napaday siya elevation diri ang atong change, no, which is napadiri nga part napa siya changes, but since dili man makita sa side scan, so mo nang makaingon ta nga dili jud siya, mo nang makaingon ang kaning side scan sonar is not reliable, no? Reliable for images, no, labi na sa kanang mga terrain, irregular na ang terrain sa ilalom. So kung flat, walay problema, no? But pag na-irregularities, no, dili jud ta ka-assure na that is reliable. So ang purpose man po ni side scan is to get, no, information labi na sa or to characterize the features, no, underwater sa katong mga dili na makaya og multi-beam, single beam, no, to have also the 100% coverage. So an interferometric side scan sonar determines the direction of the signal from observed difference in travel time. Same lagi hapon sa pamaagi ni multi-beam and single beam. Difference in travel time times the speed of sound in the water. Then such a system consists of limited number of transducers, for example, or transducer arrays, in order to get a narrow beam for each array mounted in the short distances from each other. Alright, so let's go on to the last part, no, of this topic, which is the part 5 that talks about the airborne laser method. So in the mid-1960s class, the use of the laser technology for measuring distances led into the experimental use of airborne laser radar or kanang LiDAR, or the light detection and ranging, for determining the topography. Okay. Since naka-realize sila, no, nga ang laser laser technology can are equipped, no, in measuring distances labi sa kanang station, for example, no, siya, and they know na or ilahang gipag yung giistadihan through experiments, no, na how this laser technology can determine topography of the land. So a laser is an electromagnetic signal in a frequency band of the optical window in the electromagnetic spectrum. So sulod ni si laser, no, ang signal ni laser nasulod siya sa electromagnetic spectrum in optical window kanang makita sa atong mata. So, propagation of the light in water, similarly to propagation of acoustic waves, depends on the three basic states variables, which namely the temperature of the water, the pressure of the water, and the salinity. Temperature, ang kainiton or kabugnawon or pila ka degree Celsius, pressure sa tubig, and salinity. Seawater is somewhat transparent to electromagnetic radiation. No? Okay, since labi na ka ng clear kayong water, no? So transparent siya, no, for electromagnetic radiation in infrared bands, no. So kung atong for example sa inyong remote sensing, no, kung nakaagi mo anang saan pag band combination para ma-reveal nato ang specific nga or unsa tong gusto nga i-reveal sa isa ka image, no? And if we are going to use infrared, no, so nga bands, so ang water is being transparent, no? So here is a example, no, or an illustration on how the laser technology or the LiDAR, no, on getting the topography of the land, in getting the topography of the seabed rather, or the riverbed. So same, no? From aircraft, meet siya og electromagnetic radiation or laser technology, no? Then as the laser technology surpasses another medium of for example from atmosphere into water, so mag-change ang iyang direction, okay, na may refraction, ang uban is ma-absorb, ang uban is ma-scatter. Then pag maabot na to siya diri sa riverbed or seabed, so mo reflect balik sa taas. Then from one medium to another medium, so gikan na pud sa water padulong na pud sa air, change na pud na po changes sa iyahang direction, then bounce back balik sa sensor which is naka-attach sa airplane. So that's merely the concept, no? Marja po siya og kanang sa remote sensing, no? That's remote sensing nga pamaagi gihapon, getting information from afar without touching the features. Okay, since ang atong technology is nagka-evolve, no, as time goes by. So here is the electromagnetic spectrum, no? So naatay different classification na gamma rays, X-rays, ultraviolet rays, and in this part, no, which is gamma kaayo, dira ang visible light. So ang visible light, ang visible lang, no, sa atong mga mata is just 2% of the electromagnetic spectrum. Then infrared rays, radar, so mga dagko na diri og frequency, low energy and high frequency. Then sa pikas is si high energy, no, high energy. So kanang gitawag nato nga Roy G. Biv, ang visible na light. Diri nga part is high energy, dulong diri sa gamma rays and X-rays. Then diri sa tikas is low energy, infrared rays, radar, FM, TV, and so on and so forth. And transparency is a function of amount of material suspended in the water. So pag mutok taog transparency, labi na sa hydrographic survey, paapekto man po ni si ang transparency sa tubig. So labi na ka nang mag-survey mo og suba or river na color of brown, no? So dili na to ma-compare ang elevation sa ilalom tungod kini mga suspended sediments. And when no suspended elements is present, attenuation is expressed in the function of absorption and scattering, while the absorption coefficient absorption quantified by the absorption coefficient, letter K. And when suspended material is present, then the absorption coefficient is replaced by extension coefficient. And due to absorption or extension, the intensity of the radiation I will decrease in the decreasing path of the laser ray. So maka-apekto jud sa transparency, no, kay ang clarity, water clarity kumbaga sa tubig, no, nga imong i-survey. So I remember no, sa akong OJT nga time, nag hydrographic survey me, then matingalan mi kay pag bathymetric survey mi, tapos lubog kayong tubig, no? Makadetect mi og kanang somewhat like matingala ka nga diri kay constant pang iyahang elevation, tapos mukalitrag ka zero, or ang constant pa ang iyang depth rather, tapos mukalitrag ka zero, tapos mubalik na pud og constant na pud sa depth niya. So nangutan ako sa nangutan ni sa unsay reasons ano. So una is pwede siya sa instrument, no, na error, or pwede pud siya, no, nga ni bounce back, nagbalik ang acoustic waves tungod sa mga suspended na sediments nga iyang na-detect sa ilalom. So mo nang importante si transparency, but don't di siya necessary nga pag lubog ang tubig is dili na siya nato pwede sorbihon, no? It's there is a coefficient na pwede nato siya gamiton, no? Kani si absorption coefficient o kani si extension coefficient para makasolve ta og reliable na data and information. So this is an example of a clear water, no? So kung magbathy ka ani, so mura kag naglargo na og validate na okay, ang changes diri kani sa ang changes elevation is na ay significant change jud. So makita nyo okay kay naa diri features no nga underwater features na makaingon ta nga nag-change yun siya. Importante pud na siya. Alright, so I guess we reached the last part of the presentation, no? So I hope that you learn from this topic, and stand by for the next videos for the next topics for hydrography, no? So again, thank you so much for watching. Keep safe everyone, and God bless.